on the module under the web assign module, there's this little shortcuts thing, right? So if you type the slash, it's going to automatically make a fraction for you, which is definitely going to help in tonight's homework. You'll see that. If it was a square root, you put SQRT, it's going to give you the square root, ABS, absolute value. So all those things help you to not have to go to the equation editor. Obviously, you can still use the little pop-up of the equation editor, but hopefully this stuff helps a little bit. We're not in the trig stuff just yet, but the other stuff should definitely help with a couple of, like, just timing, having to go to the, the equation editor every time. All right, where'd my gallery go? I lost you guys. Okay, like I said, we are going to do the note. Okay, so again, chapter P5, part A, well, they're all rational expressions, but part A, we're just going to learn how to simplify the rational expression. A rational expression is just like a fraction, okay? Some of them are going to have numbers, some of them are going to have numbers and variables, some of them are going to have polynomials, all that good stuff. So first thing about there's restrictions that can be placed on fractions, okay, which is based on the domain of that fraction. So the domain of an expression is all real numbers, except if one of the following occurs. If there's a variable in the denominator, so let's say I have something like 3 over x, for example, okay? When I put a variable in the denominator, I have to worry about something called a restriction, okay, which says that the denominator can't equal 0, because what happens when you divide by 0? It's actually undefined, right? So if 0's in the top, it's 0. But if 0's in the bottom, it's undefined. And we can't have an undefined answer. So if there's a variable in the bottom, okay, we restrict it by saying that whatever's there could not equal 0. So in this case, my restriction would be that x cannot equal 0. So if you ever get asked for a restriction, or you see something like in the directions where you get given a fraction, but then it says assume that x can't equal this, that's why that's happening. If there's a variable in the denominator, that denominator can't be 0. So there's something called a restriction on your domain. Domain is just what you can plug in for x. If there's a variable under a square root, and if there's a variable under a square root in the denominator, so under a square root, this number can't be negative. We would say that's greater than or equal to 0. And if it's in the denominator, we would say it can't be negative and it can't be 0, so it'd be greater than 0 instead of greater than or equal to. The bottom two are not going to happen right now. What you want to pay attention to is the top one. So again, if I've got a variable in the in the denominator, then I have to make sure that it does not equal 0, because if that denominator equals 0, then my entire fraction is undefined. So we're going to start with simplifying fractions, okay? If you look at the ones on the left here, these can be simplified. The ones on the right cannot be simplified. So if I look at the left, I would say both 6 and 30 are divisible by 6. It would go into itself once and into 30 5 times, and that's how I would simplify that fraction. So simplifying fractions. If you look at 3x over xy, this is all multiplication. Both of them have an x, so I can actually cross through the x, and this would be 3 over y. If you go to the next one, I have 2 and 5. That part can't be reduced, but I have the exact same expression, x plus y and x plus y, which means those can be canceled, and I'd end up with just 2 over 5. If you look at the next one, I have 2x plus y and 5y plus x. If it's a plus in the middle, the order does not matter, right? 2 plus 3 is the same thing as 3 plus 2. So if it's a plus, the order doesn't matter. I can cross those out, and again, I would get 2 over 5.
I'm confused for the 3 over y one. I thought we weren't supposed to have a variable in the denominator.
So that's if it asks you for a restriction. You can have a variable in the denominator. You would just say, if it asks you for a restriction, you would say x and y cannot equal 0.
Oh, okay.
But you can have it in the denominator. You just have to make sure what's there does not equal 0.
Okay.
Then the last one, now this is not exactly the same. X minus y and y minus x are opposites. They're the same variables, but with opposite signs. So when we reduce this, it's actually a -1. And the reason that works is if I had taken out a -1 in my denominator, let's say I do that, I get -y plus x. And now these are the same. and I'd end up with 1 over negative 1, which ends up as negative 1. So those can be reduced if they are opposites, meaning exact same variables but opposite signs. Then I would make it a negative 1. Okay, now look at the ones that can't be simplified. So this is where mistakes are made that shouldn't be made. For as long as I have been teaching, I see things like, I'm going to cross out that x and that x. You cannot do that. If there's a sum, this entire thing is a partnership. It's its own term, which means you cannot cancel x plus 3 with anything other than x plus 3 or 3 plus x. So you cannot cancel out part of a sum with part of a product. Okay, you can't cancel that way. So this one doesn't get simplified. If I look at the next one, I get 2x minus y and 5x plus y. These are not opposites. One is a plus and one is a minus. These cannot be simplified. So the difference between these two is that the one on the left that can be simplified, they both have a difference. It's just that they're opposite signs. Questions?
I don't understand why the 2/5, like the one that you just talked about, I don't get why that one can't be simplified.
So is 1 minus 3 the same thing as 1 plus 3?
No.
So x minus y is not the same thing as x plus y.
Okay.
So if one's a plus and one's a minus, they cannot be crossed through. It has to be exactly the same or the opposite. So I could have done negative x plus y. These are the opposites. That would have crossed out and given me a negative 1. It's still not crossing completely out. But you cannot cancel a sum with a difference.
Okay.
Does that make sense?
Yeah.
Okay.
Thank you.
You're welcome. All right, let's work through some examples. And again, we're going to kind of baby step our way in. So number 1 is 4 over 20. Is there something that goes into both of those?
The number 4.
Good. So 4 would go. That would give us 1/5. Number 2, I've got x times y and w times y. Because it's multiplication, we can cancel through the y's, and we end up with x over w. Number 3, I cannot cancel this x with this x because that x is with the 1. So that's like a little protected package that you can't break up just part of it, which means my overall answer cannot be simplified, and that would be the same. Number 4, I can cancel through both the x's, and I get left with just x plus 1. All right, so for some of these, when we get to number 6, we're actually going to have to factor these first and then cross through what we can. If you look at number 5, I've got 3x and then 6x to the second. 3 and 6 are both divisible by 3, so this becomes a 1, this becomes a 2. And one of the x is going to get canceled, and I end up with 1 over 2x. If this was reversed, so I need the 1 in the numerator because there's nothing, when I cancel it all out, it doesn't mean there's a 0 there. It means there's a 1. If this was reversed and the 6x was in the top and I canceled through, I would technically have ended up with 2x over 1, and I don't need the 1. That answer would have just been 2x. All right, we're going to go to 7, and then we're going to go to 6. So 7, 18, and 60 are both divisible by 6. 18 divided by 6 is 3, 60 divided by 6 is 10, and then I can cancel out 2 of the x's here, leaving 3 in the bottom. And then my answer is 3 over 10x to the third. Now, if you had, instead of doing divided by 6, divided by 3, I would have ended up with this, 6 over 20x to the third, and then that can get reduced again. Either way, you end up with the same answer. Number 6, x squared plus 4x minus 12. Here we have to factor. So I'm looking for the factors of negative 12 that sum to positive 4. One's got to be positive, one's got to be negative, but the positive is bigger because of the positive in the middle. So I end up with negative 2 and positive 6. That becomes x minus 2 squared and x plus 6 squared, or sorry, not squared, x minus 2 and x plus 6. And then in the denominator, I can take out a 3, and I end up with 3 over x squared, x minus 2. The x minus 2's cancel, and what's left is x plus 6 over 3. Number 8, if I factor the numerator, I'm looking for the factors of negative 20 that sum to positive 8, which is negative 2 and positive 10. Factor that out, and I'd get x minus 2 and x plus 10. The denominator, I'm looking for factors of positive 10 that sum to positive 11, which are 1 and 10. And I get x plus 1 and x plus 10. Then the x plus 10's cancel, and I'm left with just x minus 2 over x plus 1. When you enter this in WebAssign, one of the shortcuts is the fraction. So if you enter it in like this, parentheses x minus 2, use the little slash, then group the denominator x plus 1, it will put it into fraction form for you. The other option is to click this little fraction icon on your equation editor and then just type your numerator in and the denominator. You wouldn't need the separate parentheses. All right. You try number 9. So I'll give you a minute to try number 9. All right, how do you factor the numerator of 9?
With 4. Take out 4.
Good. Take out the 4 and I get x plus 3. How do I factor the denominator of 9?
X minus 6, x plus 3.
Good. So then my x plus 3's are going to cancel, and I end up with 4 over x minus 6. So again, in WebAssign 4 dash, it's going to bring you to the fraction, and then x minus 6 in parentheses. Or use the little the little fraction symbol and just type it in. And I cannot simplify, like I can't cross the 4 and the 6 and make this 2 and 3, right? Because 6 is partnered with x, and it can't be broken apart, okay? I can't cancel something that's not the sum into the sum. All right, number 10. Okay, so the top is 12 plus x minus x squared. This time, okay, the x squared comes last. So I have factors like this. One of these x's has to be negative. And then I'm looking for the factors of 12 that would be plugged into that first space with a difference of only 1. So the difference of 1 would be 4 and 3, right? So I can put the 4 here and the 3 here. Try that. That's negative 4x plus 3x. So my numbers are right, but my signs are wrong. So I would switch. Make this the minus, this the plus. Now I get positive 4x minus 3x, and that gives me the x in the middle. So my numerator is that, 4 minus x and 3 plus x. Now the denominator, okay, is 2x squared minus 9x plus 4. There's a number on the front, but that 2 is prime. So I might try my trial and error or do the first and last, whatever you're comfortable with. But if I did trial and error, it would be 2x and x. And then factors of positive 4. I need the middle to be negative, which means they're both going to be negative. I can try 1 and 4 and 2 and 2. So let's try the 1 and the 4. Multiply the outer, that's negative 8x. Multiply the inner, negative 1x. And there's my negative 9x. So I got lucky this time. The first one I tried was the one that worked. Okay, it's not always going to be like that. So if you'd rather do the first minus the last, that's fine. First times last, sorry, that process. Okay, so now I'm here, right? So I need a factor, or I need to simplify what's there. I have a 4 minus x, a 3 plus x, a 2x minus 1, and an x minus 4. Nothing is exactly the same, but if I look at the 4 minus x and the x minus 4, those are opposites. Same numbers, but the different signs, right? So I can cancel one, cancel the other, and do a negative 1. That negative can be in the numerator. It could be out front, so I could put it like this. Or I could distribute it in, but just to one or the other. So if I'm going to distribute it to the top, negative 3 minus x over 2x minus 1, don't distribute it to both. So either of these answers would be right. Negative out front, 3 plus x over 2x minus 1, or the negative to get distributed in just the numerator.
Can you scroll up so I can see the whole problem, please?
Mm-hmm. All right, 11. Now I've got another term on the front, but again, it's prime, so it's probably easier to do trial and error. Let's do it. 3x and x. And then it's a negative 2, which means it's either positive 1, negative 2, or negative 1, positive 2. So let's try plus 1 minus 2. Outer is negative 6x. Inner is x. That does not give me a negative x. So I switch them. Negative 2, positive 1. Outer is 3x. Inner is negative 2x. That's a 1x. So my number's right. My sign is wrong. All I have to do is switch the signs. This becomes plus. This becomes minus. And now it's negative 3x, positive 2x, which is the right sum, negative x. So that's my numerator. I'm going to rewrite it down here so we have space. Denominator, parentheses again. The x is at the end. This time one's positive, one's negative. So x and negative x, positive and negative. And now I'm looking at the factors of a positive 5. I need a negative 4 as my sum. So it's 1 and 5 or 5 and 1. I do 1 and 5, multiply outer, negative 1x, inner, positive 5x. The right number, but the wrong signs. So I switch the sign. Minus plus, and now I get positive x minus 5x, which is negative 4x. That's the right combination for my denominator. So I've got 3x plus 2 times x minus 1 over 1 minus x and 5 plus x. Nothing is exactly the same, but again, we've got these opposites. So I'm going to put a negative 1 on the front, and I'd end up with negative 3x plus 2 over 5 plus x. Or I can distribute that negative in, and I can use either of those answers. The first is less work, so use it, okay? You don't have to distribute the negative in. 12 in my numerator, I can take out a 4, and I get 3 minus x. The denominator, x minus 3. They're not the same, but they are opposites, so I put the negative 1 out front. Negative 1 times 4 is just negative 4. Questions on those? All right. Last slide. Still the same concept, just extra examples. So number 13, how do I factor the numerator?
It's between two squares.
Good. Difference of two squares. X plus 5. X minus 5. Denominator is 5 minus x. Okay? Not exactly the same, but x minus 5 and 5 minus x are opposites. I put the negative out front. Because it would be negative parentheses x plus 5, and we don't really want the parentheses, there's no denominator there, I can distribute this in. Negative x minus 5. I think WebAssign, if it was something like this, will take either answer. But if you find it's not taking the first, then you can skip to that second one. Just distribute in the negative. Just make sure if you're doing the first one, you leave the parentheses.
Since this is factoring still,
Yeah.
Could we still use like the property where like when there's the three and like you multiply the first
Yes,
and the last?
yes. So I'll do, I think there's one. Yeah, I'll do number 15 like that. Yes, you can of course use that.
Okay, thank
Yeah,
you.
you're welcome. Okay, 14, 4x minus 8x squared. So I can take a 4x and I get 1 minus 2x. And in the denominator, I can take out a 5 and I get 2x minus 1. So on the front, I've got 4x and 5. That's not going to reduce. And then I've got 1 minus 2x and 2x minus 1. These are opposites. I'm going to put a negative 1 out front. And I end up with negative 4x over 5. Okay, number 15. So numerator has the variable at the end. So let's do that first. This would be a positive x and a negative x. And then I need the factors of positive 4 that I end up getting a positive 3. So I can do 4 and 1. Outer and inner would be negative 4x and positive x. That gives me a negative 3. Right number, wrong sign. So switch my signs. Now I get positive 4x minus 1x, which is 3x. There's the one that works. So that's my numerator. Okay, denominator. So Audrey, I'll do this one with the first and last. If I multiply first and last, 2 times negative 4, I get negative 8. Find the factors of negative 8 that sum to negative 7, which is positive 1 and negative 8. Replace the middle term with those, so positive 1x, negative 8x, minus 4, and then factor by grouping. Take out an x, take out a negative 4, and I get 2x plus 1 and x minus 4. That's the denominator. Nothing is exactly the same, but I've got opposites again, here and here. So the negative 1 goes out front, and I'd get negative 1 plus x over 2x plus 1.
And when you're doing that, like, if I were to put the negative 8x before the positive 1x, it wouldn't matter?
Nope, doesn't matter. The order would be different. You'd have 1 plus x times 4 minus x, but the 4 minus x is still going to cancel out.
Okay, thank you.
You're welcome. All right, everybody still okay? All right, last one. 16 says x squared minus 1 over x to the third plus x squared plus 9x plus 9. Now we're doing difference of two squares and factor by grouping. You try it. See how far you can get. All right, how do we factor the numerator?
X plus 1 times x minus 1?
Good. How about the denominator? I'm going to group it, right? Well, let me do it a different color. I'm going to group it. What can I take out of the x to the third plus x squared?
X squared.
And I'd get x plus 1. What can I take out of the 9x and the 9?
9.
9. And I get x plus 1. And I end up with x plus 1 times x squared plus 9. There's my denominator. All right, then what can get canceled out?
X plus 1.
Good. And I end up with x minus 1 over x squared plus 9. It is very unusual that something doesn't cancel out. So if you find that you got to a point in which you can, not to say that it'll never happen, but it is very unusual. So if you get to the point that you factored the denominator and you're like, wait, nothing's going to cancel out, go back to your factoring and make sure that it looks like it's right. If you're really good at difference of two squares and you factor that and you look at the bottom, you should say something should be there for me to cancel. So there's probably either an x plus 1 or an x minus 1 or something like that for me to be able to cancel. So keep that in mind, okay? These, like I said, it's very rare that nothing cancels out. It can happen, but it's pretty rare.
If in that last problem, if instead of instead of x squared plus 9, it was x squared minus 9, then that would be the difference between two squares, right?
Great question. Yes, if this was a minus instead of a plus, then I would then take that and break it down to x plus 3 and x minus 3. Nothing else will cancel, but I can then have that as my denominator.
Okay.
Yep.
Thank you.
You're welcome.
Can you go to the page before this, please?
Sure.